Hey guys, how's it going? All right, so moving through our rational functions unit. This is chapter 9 in the textbook. And guys, if you're in class with me, this is the last unit that we do. Okay, so this topic comes 9.2 called analyzing rational functions. So first example says we have a rational function x squared minus x minus 6 over x minus 3. Instructions say factor and simplify the function. So to do that, well, we can factor this expression as x minus 3 times x plus 2 in the numerator, and the x minus 3 factors are going to cancel out. So we get x plus 2. Okay, so what the question says, sketch the graph of the resulting linear function. Okay, so there's going to have a y-intercept of 2 and a slope of 1. Okay, so from here, like this, we're going to have a graph that looks like this. Okay, so here's the linear function that we're looking at. Okay, now what it says is what non-permissible values are there. Okay, so what this is saying over here is x cannot equal 3. Okay, so we look at our denominator over here. If x equals 3, we have 3 minus 3 in the bottom, so that's not going to work. Okay, so what we get from here is when we look at x equals 3 here, okay, there's actually going to be a little hole in the graph like this. Okay, so this is actually an undefined value for this function over here, and the reason why it's undefined, guys, is because we're saying that this is equal to this, except x cannot equal 3. So that's what we're saying by that. This is equivalent to this, but it's not true for x equals for x cannot equal 3 because it's a non-permissible value on the left-hand side over here. Okay. Guys, I'm going to just open up Desmos for a second here. So when we graph what we see here is we do see this linear function over here, but what you see over here, if I can just quickly drag over here, when x equals 3, it says 3 comma undefined. Okay, and over here we see there's this little open circle, okay, in the graph. So what we have here, I'm going to put up kind of 3 comma 5, and I'm just going to fix this over here a bit. What we're seeing for this point here is like we have this point, okay? So the notation on our graph that we're going to use here is we have our linear function, which is looking just like a regular linear function over here, but we have this point, which we call a point of discontinuity, okay? Okay, so this is what we call this. It's called a point of discontinuity. That means it's going to be, this point is excluded from the graph. Okay, so back to our notes over here. What is the restriction on the domain and the restriction on the range? Okay, so the restriction on the domain is x can be any real number, but it can't equal 3. And our range is y can be any real numbers, but it cannot equal 5. Okay, so it's been excluded from the domain and the range for this question over here. Okay, given the function x minus 3 over x squared minus 9, factor and simplify the function. So in this case, okay, we have x minus 3 over x minus 3, x plus 3. So the x minus 3's factors cancel out, and we have a 1 in the numerator. And leaves us with 1 over x plus 3. Okay, so we talked about functions similar to this in our last section. Okay, so this means when we have an x plus 3 in the bottom of this, we have a vertical asymptote at x equals negative 3. And this is like the same thing, saying plus 0. So that means we have a horizontal asymptote at y equals 0 here. and this a value is 1, so we have a point here, point here. This graph is going to look like this. Okay. Now, for the part B over here, we've sketched the graph, but we have a point of discontinuity. Now, here's where the point of discontinuity happens. In our original, I'm just going to rewrite this guy over here again. We really have two non-permissible values. We have x cannot equal 3 and negative 3. So I'm just going to list this as part of my domain over here. Okay. So for the negative 3 part, that's going to lead to, so the part over here is our vertical asymptote over here. But see how the one which canceled out? If you have two factors which cancel out, they don't lead to discontinuities, or to points, to vertical asymptotes. They lead to points of discontinuities instead. Okay, so I'm going to make a little note of this. When factors cancel out, those NPVs lead to points of discontinuity. Okay. When the factors don't cancel, those NPVs lead to vertical asymptotes. All right, so in this case, again, this one did not cancel, so we have the vertical asymptote. Now, we have this point of discontinuity. How do we figure out the point of discontinuity? Well, we know that our non-permissible value was 3 for this guy over here. Well, what I'm going to do is I'm just going to put that into this function here. 1 over 3 plus 3 is 1 over 6. That means at this point here, so when x equals 3, 3 comma 1/6 is our point of discontinuity. Okay, what's our domain and range? Our range is y cannot equal 0, and that's for our horizontal asymptote here, but it could also not equal 1/6. Okay, and that's going to be the y value of our point of discontinuity we must exclude from the range. So here is our domain and range for this function. Given the function, factor and simplify the function. Okay, so we have x squared minus 5x over x squared minus 25. Okay, so we have x over x plus 5. Okay, so we're going to have a point of discontinuity. Let's go ahead and do that first here. Our point of discontinuity, POD, we'll use that for short. Well, the factor that canceled out was x minus 5. Therefore, x coordinate is 5. Okay, so our x coordinate equals 5, and that was from the factor that canceled out. All right. So this factor that canceled out. Now the way we figure out our y value is like, well, in my simplified version, x over x plus 5, I'm just going to plug in this value. 5 over 5 plus 5 is 5 over 10, which is 1/2. Okay. So 5 comma 1/2 is our point of discontinuity. Okay. I'm going to put that here. 5 comma 1/2 would be this point right here, and there's our point of discontinuity. Part B, convert the resulting rational function, that's this guy over here, into the form this one. So we did that. We covered this in our class. So the way we did it, we're going to use some long division. And we're going to say x plus 5 goes into x. I'm going to put this as x plus 0 over here. x divided by x is 1, times x plus 5, we subtract, we get negative 5. So when we divide these guys over here, we're left with this expression here, which is negative 5 over x plus 5 plus 1. That means we have this horizontal asymptote, we have this vertical asymptote. Our stretch factor is 5. That means here I'm going over 1 up 5 to here. This graph is going to look like this. And then if I go over 1 down 5 to here, this graph is going to look like, oops, should have been a bit steeper over here. Let me just redraw this. Should have looked like this guy over here, okay? So we have this point of discontinuity, which was 5, 1/2, like this. Our domain, our range, guys, just experience from marking this stuff for a while now. People tend to forget about the y value of the point of discontinuity when they're writing the range of these type of functions over here. Okay, so we just need to make sure that we're including both these values. So this 0 is from the asymptote. I'm sorry, guys, I totally made a mistake. It's not 0. That was actually y cannot equal 1 because that's where our horizontal asymptote is. And then this x and this y have to be excluded from the from our domain and our range as well. Okay, the function has a point of discontinuity at p, q, a horizontal asymptote of x equals h, and a vertical asymptote of y equals k. The value of p times q times h times k equals blank. Okay, so when we do this here, we're going to factor our numerator. We have a common factor of 3x, so we'll factor that out. Our denominator factors 2. So I think this is going to work like this. Okay, and those guys count out here, equals 3x over x minus 2. Now I'm just going to do off the side here and do my long division. So 3x divided by x is 3, and we're left with 3x minus 6. Subtract them. 0 minus negative 6 is 6. So this equals 6 over x minus 2 plus 3. Okay, so that's what this guy is going to equal to in our form over here. So 6 over x minus 2 plus 3. All right, so what do we know so far? We know that x equals 2 is our vertical asymptote. Therefore, h equals 2. Y equals 3 is the horizontal asymptote. Therefore, k equals 3. Okay. We know that now we need to figure out what our point of discontinuity is. Okay. Well, the factor that canceled out was x plus 3. So I'm going to say x plus 3 canceled out. Therefore, negative 3 is x value of point of discontinuity. Okay. So how do we figure out our y value? Well, I'm going to plug in my negative 3 into this value over here. Okay. So 6 over negative 3 minus 2 plus 3 is negative 6 over 5 plus 3. Now I'm going to add two fractions here, so I'm just going to multiply this guy times 5 times 5. Negative 6 plus 15 is 9 over 5. Okay, so our point of discontinuity is negative 3 comma 9 fifths. Okay. All right. So the value of P times Q times H times K. So this is like our PQ. We have P times Q is going to be negative 3 times 9 fifths, like that. Okay. We have times our H value, which is 2, times our K value, which is 3. I'm just going to do this with my calculator here, guys. So guys, this will not probably be a test numerical response question because I think we're going to get a negative value over here. But either way, it's still how we would do this answer here. So we get 3 times 9 fifths times 2 times 3 is negative 32.4. Okay, so that would be the answer for this guy over here. Okay, example 5. The function has domain and a range of this. The values of A, B, C, and D are blank. Okay, so first of all, let's factor this guy. So my numerator can factor up to 7x and x, and I think it's going to work as if I go minus 4 and positive 7. So 7x squared minus 28x plus 7x is negative 21. 7 times negative 4 is negative 28. Our bottom is a difference of squares, x plus 1, x minus 1, like this. Okay, now also in the numerator, 7x plus 7, probably should have done this in the first step, but I have a common factor of 7 here, is 7 bracket x plus 1, x minus 4 over x plus 1. These guys cancel out. So this is going to be like 7x minus 28 over x minus 1, like this. All right, so this is our guy. Okay, so we know that our point of discontinuity, the x plus 1's cancel out, therefore our negative 1 is our x value. How are we going to figure out our y value? We're going to put negative 1 into the simplified function. So 7 times negative 1 minus 28 over negative 1 minus 1 is negative 7 minus 28 is negative 35 over negative 2, which is 35 over 2. Okay, so 35 over 2 is this point of discontinuity right here. Okay. All right, so there's our point of discontinuity. Now let's convert this into the form y equals a over x minus h plus k. Now we're doing this because we need to figure out what our horizontal asymptote or this k value is going to be. So if I'm going dividing x minus 1 into 7x minus 28, 7x divided by x is 7. I multiply 7x minus 7. Negative 28 minus negative 7 is negative 21. So this equals negative 21 over x minus 1 plus 7 is my answer. Okay, so our domain is x cannot equal plus or minus 1, where x is a real number. Our range is y cannot equal 35 over 2 or 7, but any other real number like this. Okay, so our domain, they're given a question in an interval notation over here, is going to be from negative infinity to -1, union with -1 to 1, union with 1 to infinity. Okay, therefore, our A value is -1, our B value is +1. Okay, our range in interval notation is from negative infinity to 7, and then from 7 to 35 over 2, and then from 35 over 2 until infinity. So therefore our C value is 7, our D value is 35 over 2. Okay, so there's our A, B, C, and D values, which is what this question was asking us. All right, guys, hope this makes sense, and I will see you in the next video.